Everything feels stable and ordinary. The table looks solid. The walls around you seem firm and unmoving when you place your hand on the table. You feel resistance. When you tap on it, you hear the familiar knocking sound. Every signal your senses send to your brain tells the same story. The objects around you exist. They are real, solid, and separate from you. This feeling is so natural that we almost never question it. From the moment we are born, our brains learn to treat the world as a collection of objects. There are chairs, trees, buildings, animals, and people. Each thing appears to have a clear boundary. Your body ends at your skin. The table begins where your hand stops. Reality seems neatly divided into separate pieces. But physics has a habit of asking strange questions about ordinary things. Instead of accepting what our senses tell us, scientists sometimes ask a deeper question. What is actually happening underneath the surface of what we experience? One physicist who loved asking these kinds of questions was Richard Feynman. Feynman had a remarkable curiosity about the world. He believed that even the simplest everyday experiences could hide profound mysteries if you looked closely enough. Rather than treating common sense as the final answer, he liked to take familiar ideas apart piece by piece and see what remained. One of those familiar ideas is the idea that objects simply exist. It sounds obvious. Of course, objects exist. You can see them. You can touch them. But science does not stop at what seems obvious. It asks what the word exist really means when we examine the structure of the universe. For example, when you say the table exists, what exactly are you referring to? Is it the wood? The atoms inside the wood? The forces holding those atoms together? Or is it the overall shape that your brain recognizes as a table? At first, this may sound like a philosophical puzzle, but it becomes a scientific one very quickly. As physicists began studying matter more deeply, they discovered something surprising. The objects we experience in everyday life may not be the fundamental ingredients of reality. Instead, they may be patterns that appear when many smaller processes interact together. This idea is difficult for the human mind to grasp because our brains evolved to deal with the world at a human scale. Our ancestors needed to recognize predators, throw stones, build shelters, and navigate landscapes. For those tasks, it was perfectly useful to think of the world as solid objects interacting with other solid objects. But nature at the smallest scales does not necessarily follow the same simple picture. The deeper scientists looked into matter, the more the idea of solid, permanent objects began to dissolve. The table that seems so stable might not be a simple thing at all. It might be a complex arrangement of smaller components constantly interacting with each other. And those components might themselves be made of even deeper structures. This leads to a strange possibility. What we call objects, tables, chairs, even our own bodies, might not be fundamental pieces of reality. They might be temporary patterns in something deeper. And once you start looking at the universe this way, the question becomes unavoidable. If the things around us are patterns rather than permanent objects, then what exactly does it mean to say that something truly exists? Let's return to the simple table in front of you. It feels solid when you touch it. Your hand cannot pass through it, and if you knock on it, the sound echoes back with a firm response. Everything about your senses tells you that the table is a dense piece of matter, a stable object occupying space. This experience feels so obvious that we rarely question it, but science often begins by questioning the obvious. Imagine that you had the ability to zoom in on the surface of that table, much like a powerful microscope that could magnify things beyond anything currently possible. At first, you would see the tiny fibers and structures that make up the wood or material of the table. If you zoomed further, those fibers would break down into molecules, groups of atoms arranged in specific patterns that give the material its strength and shape. If you zoomed even deeper, you would begin to see individual atoms. For a long time, scientists believed atoms were the smallest possible pieces of matter. The word tom itself comes from an ancient Greek idea meaning something that cannot be cut into smaller pieces. Early thinkers imagined atoms as tiny, solid spheres like miniature billiard balls forming everything in the universe. But when scientists eventually developed tools and theories powerful enough to explore atoms more carefully, They discovered that this picture was completely wrong. An atom is not a solid ball. Instead, it has a tiny nucleus at its center, containing protons and neutrons, while electrons occupy regions around that nucleus. But the most surprising part is not the structure itself. The surprising part is the scale. The nucleus of an atom is incredibly small compared to the entire atom. If you were able to enlarge an atom to the size of a huge sports stadium, the nucleus would be about the size of a marble sitting quietly at the center of the field. The electrons would exist as a kind of cloud far away from it. Everything in between would be empty space. This means that the table in front of you, something that feels hard and solid, is actually made mostly of emptiness. The atoms that form the table are spaced in such a way that vast regions of space exist between their tiny nuclei and their surrounding electrons. Your hand is made of atoms too, so when you press your hand against the table, something unusual is happening. You might imagine that the atoms in your hand are physically touching the atoms in the table, but that is not really what occurs. The electrons in the atoms of your hand repel the electrons in the atoms of the table through electromagnetic forces. These forces push the atoms away from each other before their nuclei ever come close to touching. The sensation you experience as touch is actually the result of those invisible forces resisting the motion of your hand. In other words, when you press on the table, you are not truly touching solid matter. What you feel is the interaction of electric forces between atoms that are mostly empty space. This realization quietly changes the way we understand the physical world. The solidity of objects, the firmness of wood, metal, or stone is not because matter is packed together like bricks in a wall. Instead, it is the result of invisible forces that create the appearance of solidity. The everyday world feels solid not because it is truly solid, but because the fundamental forces of nature prevent atoms from passing through each other easily. What your senses interpret as a solid object is actually a delicate balance of particles and forces maintaining a stable structure. The deeper scientists look, the more the familiar idea of solid matter begins to dissolve into something far more surprising. If we continue this journey deeper into matter, the story becomes even more surprising. At first, discovering atoms already changed the way scientists thought about the world. But the moment scientists believed they had reached the smallest building blocks of nature, new experiments revealed that atoms themselves were not fundamental. Inside the nucleus of every atom are particles called protons and neutrons. For a while, physicists believed these particles might finally be the true indivisible pieces of matter. But once again, curiosity pushed them further. When powerful particle accelerators were built and experiments began probing deeper into the structure of these particles, scientists discovered something else hiding inside. Protons and neutrons are themselves made of smaller particles known as quarks. At this point, the picture of reality began to change dramatically. Matter was no longer a collection of tiny solid balls stacked together. Instead, it looked more like a layered structure where each level revealed something even more fundamental beneath it. But modern physics goes one step further. According to our best current theories, the smallest components of the universe may not really be particles in the traditional sense at all. Instead, they appear to behave like tiny excitations in invisible fields that fill all of space. This idea comes from a powerful framework known as quantum field theory. In this view, the universe is not primarily made of objects. Instead, it is made of fields that exist everywhere, even in what we call empty space. There is an electron field spread throughout the entire universe. There are quark fields, photon fields, and many others. These fields are not located in specific places. They are present everywhere, quietly existing even when nothing seems to be happening. What we call a particle is simply a tiny disturbance in one of these fields. A useful way to imagine this is by thinking about the surface of the ocean. When you look at the ocean, you might see waves moving across the water. Each wave seems like a separate thing traveling through space. But the wave is not actually an object in itself. It is a pattern of motion in the water. The water is the underlying substance. The wave is simply a temporary shape that forms when energy moves through it. In a similar way, An electron may be like a wave traveling through the electron field. It is not a tiny solid ball flying through space. It is more like a ripple appearing in a field that already exists everywhere. If the field were removed, the particle would disappear, just as a wave disappears if there is no water. This idea changes the meaning of what a thing is. Instead of objects being fundamental pieces of reality, they become events or patterns that occur within deeper structures. The electron in an atom is not a permanent little bead. It is a localized vibration in the electron field. A photon of light is a vibration in the electromagnetic field. Even the particles inside the nucleus are understood in this way. From this perspective, the universe starts to look less like a collection of tiny marbles and more like a vast ocean of interacting fields. Particles appear and disappear as ripples in those fields, forming the structures we observe. The table in front of you, which once seemed like a solid object, is actually an incredibly complex pattern made from countless tiny field vibrations interacting with each other in stable ways. And the same is true for your body. Every atom in your body is built from these same underlying fields. Every particle inside those atoms is a tiny ripple in the fabric of the universe. So the objects we see around us may not be fundamental things at all. They might be temporary patterns emerging from something deeper, something more abstract than our everyday intuition was ever designed to understand. Now bring this idea closer to something much more personal, your own body. At first, it feels obvious that your body is a solid, stable object. You can see your hands, feel your heartbeat, move your muscles. Your body seems like a clear physical thing that exists continuously from one moment to the next. But when we examine the body through the lens of physics and biology, a different picture slowly begins to appear. Your body is made of cells, trillions of them. Each cell is an incredibly complex system made of molecules, and those molecules are built from atoms. We already know that atoms are mostly empty space, and that the particles inside them behave more like ripples in fields than solid objects. But even without going that deep, biology alone reveals something surprising about your body. It is constantly changing. Right now, as you sit and read this, millions of chemical reactions are happening inside you every second. Your cells are taking in oxygen, processing nutrients, producing energy, repairing damage, and building new molecules. None of this ever stops. Your body is not a fixed structure. It is an ongoing process. Consider the atoms inside you. The oxygen atoms in your lungs were floating in the air only moments ago. With every breath, new atoms enter your bloodstream and travel through your body. The carbon atoms that form parts of your muscles and organs likely came from food you ate days or weeks ago. At the same time, atoms are constantly leaving your body. When you exhale carbon dioxide, atoms that were part of your cells just moments before are released back into the atmosphere. Sweat carries atoms away from your skin. Every movement and every breath slowly exchanges matter between you and the environment. Over time, this exchange becomes enormous. Scientists estimate that over several years, a large portion of the atoms that once formed your body are replaced by new ones. Yet, despite this constant turnover, you still experience yourself as the same person. This raises an interesting question. If many of the atoms that once formed your body are gone, what exactly remained the same? The answer appears to be the pattern. Your body maintains a particular organization of matter. Even though individual atoms come and go, the overall structure, the arrangement of cells, tissues, and organs continues. The body preserves its form by constantly rebuilding itself. A helpful way to imagine this is to think about a whirlpool in a river. When you watch a whirlpool spin in the water, it looks like a stable object. You can point to it, you can watch it rotate for minutes or even hours. But if you could track the individual water molecules inside the whirlpool, you would discover that they are constantly changing. Water flows in and flows out. The molecules inside the whirlpool at one moment are not the same ones a few seconds later, yet the whirlpool remains visible. What exists is not the water itself, but the pattern created by the motion of the water. Your body may be something very similar. The atoms that form your cells are like the flowing water. They move in and out continuously. What persists is the structure, the pattern that organizes them into a functioning system. This means that your body might not be best described as a permanent object. Instead, it might be more accurate to think of it as a stable process, an ongoing flow of matter and energy that maintains a recognizable form for a period of time. From this perspective, you are less like a statue carved from stone and more like a whirlpool in a cosmic river, continuously formed and reformed by the movement of atoms through the structure that we call a body. As we continue exploring deeper into the nature of reality, the picture becomes even more unusual when we enter the world of quantum mechanics. At the level of everyday objects, things seem simple. A ball is either here or there. A chair sits in one place. A table does not suddenly appear on the other side of the room without moving through the space in between. Classical physics, the physics that describes the motion of planets, falling apples, and moving cars, follows this intuitive logic. But when scientists began studying matter at extremely small scales, atoms, electrons, and photons, they discovered that nature does not behave in such a straightforward way. One of the most surprising discoveries was that tiny particles do not always behave like tiny objects. Sometimes they behave like waves. Sometimes they behave like particles, and sometimes they behave like something that seems to be both at the same time. This strange behavior was first revealed in experiments where particles such as electrons were fired toward barriers with narrow openings. Instead of acting like small bullets traveling through a single path, electrons produced patterns on a screen that looked exactly like wave interference patterns, similar to ripples in water overlapping each other. Even more puzzling was what happened when scientists tried to observe which path the electron actually took. When detectors were used to measure the path, the wave-like interference pattern disappeared. The electron suddenly behaved like a particle again, passing through one opening instead of both. Before the measurement, the electron seemed to exist as a spread-out wave of possibilities. After the measurement, it appeared at a specific location. This led physicists to describe particles using something called a probability wave. Instead of saying an electron is at a precise point in space before we observe it, quantum theory describes a range of possible locations, each with a certain probability. Only when an interaction occurs, when something measures or interacts with the particle, does one of those possibilities become a definite outcome. This idea is difficult to visualize because our everyday experiences never behave this way. A tennis ball does not exist as a cloud of possibilities across the court before you look at it. But electrons and other quantum particles appear to follow different rules. Even physicists who worked with these theories admitted how strange they were. The mathematics of quantum mechanics is extremely accurate. It predicts experimental results with astonishing precision. Yet the underlying meaning of the theory remains mysterious. Richard Feynman once expressed this mystery very directly. He said that nobody truly understands quantum mechanics, not because the equations are unclear, but because the reality they describe does not match the intuitive picture of solid objects moving along clear paths. Instead of definite trajectories, quantum systems are described by probabilities. Instead of fixed properties, particles seem to acquire specific values only when interactions occur. This suggests something profound about the nature of reality. The universe at its most fundamental level may not consist of well-defined objects quietly existing in specific places. Instead, it may consist of possibilities that become actual events when interactions take place. In other words, the world we observe might emerge from deeper layers of uncertainty and probability. The table in front of you feels stable and predictable because it contains an enormous number of particles interacting together. At large scales, the strange behaviors of quantum systems average out, producing the familiar solidity and stability we experience in everyday life. But underneath that stability lies a world that behaves in ways our intuition struggles to comprehend. Reality at its smallest scale is not simply a collection of tiny objects. It is a dynamic system governed by probabilities, interactions, and patterns that only sometimes resemble the solid world we think we understand. As these discoveries accumulated, physicists slowly began to change the way they described reality. Earlier scientific thinking treated the universe as a giant machine built from solid pieces. Planets were objects moving through space. Atoms were tiny balls forming matter. Everything seemed to be made of clearly defined parts interacting with one another. But the deeper scientists looked, the harder it became to maintain this picture. Atoms were not solid. Subatomic particles were not simple objects. Quantum behavior suggested that particles did not even possess definite properties until interactions occurred. The closer we look at nature, the more the idea of fixed objects begins to fade. Instead, many physicists started thinking about the universe in terms of processes rather than things. A process is something that happens. It is activity rather than a static object. Fire is a process. A flame looks like a stable shape, but it is actually a continuous chemical reaction. Fuel and oxygen combine, releasing heat and light, while new gases move away from the flame. The shape appears steady even though the molecules involved are constantly changing. Living organisms behave in a similar way. Your body feels like a single object, but it is really a vast network of processes happening simultaneously. Blood circulates, oxygen moves through cells, nutrients are broken down and rebuilt into new molecules. Neurons send electrical signals across the brain. None of these processes ever stop while you are alive. If they stopped, the structure that we call the body would quickly fall apart. In this sense, your body is not a static object at all. It is an organized flow of matter and energy maintaining a particular pattern over time. The atoms move in and out, the molecules change, but the overall structure remains stable because the processes continue. This idea becomes even more interesting when we consider the brain. The sense of self, the feeling that there is a stable I experiencing the world, feels incredibly real and continuous. Yet neuroscience shows that the brain is made of billions of neurons constantly sending electrical signals to each other. These signals change every moment. Neurons fire in complex patterns that shift depending on what you see, hear, remember, or think. The brain is less like a static object and more like a constantly evolving network of activity. Your thoughts, memories, and perceptions emerge from this ongoing activity. There is no single neuron that contains your identity. Instead, your sense of self appears to arise from patterns of communication across many parts of the brain. From this perspective, the self might also be understood as a process rather than a fixed thing. Physics supports a similar idea at the deepest levels of matter. What we call particles can be seen as temporary events occurring in underlying fields. These events appear, interact, and disappear while the fields themselves remain. Instead of a universe built from permanent pieces, we may be looking at a universe built from interactions. Everything that exists might be part of a continuous network of relationships and processes unfolding through time. This view changes how we think about boundaries as well. It is easy to imagine that the edge of your skin clearly separates you from the rest of the world. But the processes inside your body constantly exchange matter and energy with the environment. Oxygen from the air enters your lungs. Heat leaves your body and warms the surrounding air. Light from distant stars enters your eyes and becomes part of your experience. Even the atoms that form your body were not originally yours. Long before Earth existed, those atoms were forged inside ancient stars through nuclear reactions. When those stars exploded, they scattered elements across space. Eventually, some of those atoms became part of our planet, our atmosphere, and finally living organisms. From this perspective, the boundary between you and the universe becomes less rigid than it appears. The matter in your body has always been part of a much larger cosmic cycle. Rather than existing as isolated objects, everything in the universe may be better understood as part of an ongoing story of transformation and interaction. When physicists began to think about reality as a network of processes rather than a collection of solid things, the universe started to look very different from the simple picture we learn in everyday life. Instead of imagining separate objects sitting quietly in space, scientists began to see a constantly changing web of interactions connecting everything. To understand this idea, imagine the universe as something more like a flowing system than a static structure. Every particle interacts with other particles. Every field influences other fields. Energy moves, transforms, and spreads throughout space and time. Even something that appears completely still, like a rock resting on the ground, is actually full of activity at the microscopic level. Atoms vibrate inside the material. Electrons interact with electromagnetic fields. Thermal energy causes constant motion within the structure. Nothing is ever perfectly motionless. The same is true on a much larger scale. Planets orbit stars, stars move within galaxies, and galaxies themselves drift through enormous cosmic structures. The universe is not frozen in place. It is always evolving. Now think again about the atoms that make up your body. Those atoms were not created when you were born. Long before Earth even existed, the universe contained only the simplest elements, mostly hydrogen and helium, formed shortly after the beginning of cosmic time. Heavier elements such as carbon, oxygen, iron, and calcium were created much later inside stars. Deep within the cores of stars, intense pressure and temperature allow nuclear reactions to fuse lighter elements into heavier ones. Over millions or billions of years, stars build the chemical ingredients that eventually form planets and living organisms. When massive stars reach the end of their lives, they explode in powerful stellar explosions that scatter those elements into space. The debris from those explosions spreads across interstellar clouds, mixing with gas and dust drifting through galaxies. Eventually, some of that material gathers together again under gravity. New stars form. Planets form around them. On at least one small planet orbiting an ordinary star, some of those atoms assembled themselves into molecules capable of copying and organizing themselves. Over time, those molecules became living systems. The atoms that now exist in your body once traveled through this enormous cosmic history. The carbon atoms in your cells were likely forged in ancient stars that died billions of years ago. The oxygen you breathe today may have once been part of a distant star's atmosphere. From this perspective, your body is not separate from the universe. It is a temporary arrangement of matter that has been moving through the cosmos for an incredibly long time. Even now, the exchange continues. Each breath you take brings atoms from the atmosphere into your lungs. Some of those atoms become part of your bloodstream and eventually part of your cells. At the same time, atoms leave your body and return to the environment. Over time, the matter that currently forms your body will move on again. The atoms will continue traveling through the natural cycles of Earth and eventually through the wider cosmos. Seen in this way, the universe looks less like a collection of separate objects and more like a vast circulation of matter and energy. Structures appear for a time, maintain their shape through ongoing processes, and then gradually dissolve as their components move on. You, like everything else around you, are part of that flow. Your body is a temporary pattern formed by atoms that have existed long before you and will continue existing long after. Rather than standing apart from the universe, you are one moment in the long and continuous movement of the cosmos itself. So what does all of this mean about who we are and how we exist? We like to think of ourselves as solid, permanent beings, separate from the world around us. We imagine that our bodies are stable objects, clearly defined from the air, the ground, and the rest of the universe. But physics and biology together tell a very different story. Your body is not a static object. It is a temporary pattern, a dynamic process formed by matter and energy moving through time. The atoms that make up your body are constantly changing, yet the pattern remains recognizable, allowing you to experience a continuous sense of self. This pattern-based view of existence changes how we think about identity. Over time, the atoms in your body are replaced, your cells die and regenerate, and your experiences continuously shape your brain. Yet, despite all this flux, there is continuity. What persists is not the material itself, but the structure, the organization of processes that allows your body and mind to function. Just as a whirlpool remains visible even though the water molecules inside it are constantly changing, you remain you, because the pattern of matter and energy maintains its form for a period of time. From this perspective, the objects we see around us, including our own bodies, are not fundamentally solid or permanent. They are temporary manifestations of deeper processes. Particles are not tiny billiard balls, they are ripples in fields that fill space. Atoms are mostly empty. And what seems solid is the result of forces interacting in a complex balance. Even the sensation of touching a table or feeling your body is mediated by electromagnetic forces between clouds of electrons. Reality at its most basic level is made of events, interactions, and patterns, not fixed objects. This understanding also transforms how we think about the boundaries between ourselves and the rest of the universe. The atoms in your body did not originate with you. They were formed in stars, traveled across space, and became part of countless other systems before arriving here. One day they will leave your body again, rejoining the cycles of matter that shape the cosmos. You are not an isolated object. You are a temporary structure in the flow of the universe, a configuration of matter and energy that appears solid only because of the ongoing processes that hold it together. Even the self, the feeling of I am, can be seen as a dynamic pattern rather than a fixed entity. The brain is a network of neurons constantly firing, reorganizing, and responding to inputs. Your thoughts, memories, and perceptions emerge from these patterns. The continuity of consciousness is not guaranteed by unchanging substance, but by the persistence of these interactions. The you that experiences the world is a pattern sustained by constant activity, temporary yet enduring long enough to perceive, think, and act. From this point of view, the universe is less a collection of separate objects and more a continuous web of relationships. Reality consists of matter and energy in motion interacting through fundamental forces and fields. Stability and form emerge from these interactions, not from inherent solidity. The universe is not made of fixed objects, it is made of processes, patterns, and events. We are part of that ongoing flow. In this light, the statement, "we do not exist," is not a denial of reality. It is a recognition that the objects we perceive, including ourselves, are temporary patterns arising from deeper processes. Our existence is real, but it is not what we usually imagine. We are dynamic arrangements of matter and energy, whirlpools in the river of the cosmos, fleeting yet meaningful manifestations of the universe observing itself. In understanding this, we see reality not as a collection of static things, but as a magnificent, ever-changing process of which we are an integral part.